Hello everyone, I am Aksha Aram and today I would like to introduce you to machine learning and a very popular algorithm in machine learning called the decision tree algorithm with some coding example. So let's get started. First, we're going to discuss about machine learning. Now, what is machine learning? Machine learning is a subset of AI and deep learning is a subset of machine learning. Here, deep learning is another term that you would come across when discussing about machine learning. It's nothing but a subset of machine learning, and machine learning it's a subset of artificial intelligence. First, the machine learning is an algorithm that can learn from the historical or past data and make predictions or decisions based on it without being explicitly programmed for that specific task. All right. So now let's discuss the process. What actually happens in machine learning? So here, the historical data, like we said, historical or past data is what happened in the previous years. Okay. So historical or past data, we can also call it a training data. Now I'll tell you why it's called training data later. So this data is fed into an algorithm. So this algorithm, like you can see the white human there, learns each pattern, the trend and the relationship between the input variable and the output variable. Why? Due to these historical data, this output has been produced. It learns the relationship. All right, it maps the relationship. Now this is what we call as a trained algorithm. Trained algorithm in the sense it has already learned the relationships and the patterns. Now this is why the historical data we feed into this training algorithm is called a training data, because it's used to train the algorithm. Pretty simple, right? Moving on, let's discuss an example so that we can establish the idea of machine learning very clearly. Now here we're going to discuss about an credit card default versus students example. Now this is a very common problem statement. Credit card default is a very commonly used. There are various problem statements based on this simple idea, but here we're going to talk about students. Okay, do students repay or default their credit card? Do they default or repay? That's the simple statement. So if a student of so and so income and so account balance would pay or not is what our algorithm is going to tell us. So we know we're gonna give if the person is student or not, their account balance and their income as input to a trained algorithm. Trained algorithm is an algorithm that has already mapped the trends and the patterns and the relationship between the variables. So when you give the input to the trained algorithm, it would give you the output if the person paid or the person defaulted. Right? So this is what basically machine learning does. Based on your input, it would predict the output. Now, let's discuss the types of machine learning. Now, there are various types of machine learning, but these four important machine learning is what we're going to learn. These are most common and very popular type of machine learning. The first one is what we see here, called as supervised machine learning. Now, supervised learning is the most common of all of these types we are going to discuss today. So what it is the training data is labeled. It's very simple. The data we give as input for training the algorithm is a labeled data. What we need to know here is what is a labeled data, right? So here's an example. I'm telling you that this is what you see in the screen is a label data. Now this data is from the previous example of credit card default versus students. Okay, so here we have the student income balance and paid or default. These are the four variables. I'm telling you this is a label data. Do you know why I tell you this is a label data? Let's look into it. So here, student income and balance is what we call as the input variable. Okay, the student income and balance is input variable because we are giving this as input to the algorithm. And paid or default is what we call as the target variable or the output variable or the outcome of the algorithm. So that's the target. Now, the input variable can also be called as independent variable because it's not dependent on anything. But on the other hand, the target variable is called dependent variable because it is dependent on the input variable. So it's called dependent variable. Clear idea, right? So what a label data is a data that has both input variable and the target variable. So if an algorithm is trained using a data that has input variable and target variable, then we call it as a supervised learning method. The second method we're going to discuss today is unsupervised learning. Now, from the name, it's easy to understand what unsupervised algorithm might be. Since we know what supervised is, can you guess what unsupervised algorithm might be? If you guessed, it's the training data is unlabeled. If you guessed it right, then congratulations. Okay, so here's what we call as unlabeled data. We know what is labeled. In unlabeled, we only have the input variable, right? In labeled, we had input and the target variable. In unlabeled data, we have only the input variable. So this is an example of unlabeled data. Student, income and balance is given as input for the algorithm to train. Then it is called unsupervised learning. Here, what the algorithm basically does is it categorizes the data into clusters. So in this case, there'll be two clusters, the default clusters and the default cluster and the paid cluster, right? Next, we have the third type of machine learning, which is semi-supervised learning. Now, semi-supervised learning, from the name, we can guess what it is. Semi-supervised, so half supervised and half is unsupervised. So it's a combination of supervised and unsupervised learning. Now, what is the requirement of a semi-supervised algorithm? Because we already have a supervised and unsupervised. Why would you want to combine it and make a semi-supervised algorithm? I'll tell you why. First is that supervised. In supervised, we need the target variable. This target variable is done manually. So it's a manual work, which is expensive, right? You have to employ somebody to do this work manually, which you have to pay them, so then it's expensive. Then in unsupervised, like we know, unsupervised doesn't have the target. So its application is limited. There's a limit to it, there's a boundary for its application. So then you can't use it for a wide range of application. To overcome these two problems, we introduce semi-supervised machine learning, which has low cost as well as a wide range of applications. Next, what we're gonna see is the fourth type of machine learning, reinforcement learning. Now, this is a very fun learning method or learning technique because researchers are still going on this technique. The algorithm doesn't have a training data set to train from. It basically learns from error and feedback, learns from its mistake like we humans do. When we are born, we say our parents teach us this is a dog, then we learn from that. That's called supervised. But if we look at a dog and we say that's a cat, and then your parents are no, that's a dog, and you learn from that mistake, that's what we call as reinforcement learning. So here what happens is taking suitable action to maximize the reward. So let's take the baby as the agent or the intelligent agent, right? And let the dog be the object. So the baby predicts the dog as cat, and the parent would say no, it's a dog. So the baby learns from the mistake. Next time it sees something similar to a dog, it would say it's a dog, and the parent will, yes, it's a dog, appreciate it and give it a chocolate. And that's chocolate is what we call as reward. Now the baby wants to maximize its reward, gets as many chocolate as possible, so it tries to predict it correctly. This is the basic functioning of reinforcement learning. Now, as told you, we have various types of machine learning. We only discussed 4 main and commonly used type. There are other types like transductive, active learning, inductive, deductive, and multitask learning. All right, moving on. So we learned supervised learning. Supervised learning is the first and foremost commonly used type of machine learning algorithm. We know what it is. It uses labeled data for training the algorithm. Now, reinforcement learning has 2 types. The first one is regression and the other one is Classification. Now we need to know the difference between regression and classification. These two are categorized based on the data type of the target variable, right? So if the target variable is continuous, then it's called regression, and if it's discrete, then it's called classification. Now what does continuous mean? It's like our age, weight, or height. So the values are continuous. It's 15.1, 15.2, 15.3, 15.4. It goes on till 16, 17, 18. So values are continuous, then it's continuous, and it would be a regression problem. If the target is discrete, it would be like the number of students in a school. So right, the number of students cannot be 14.4 or 14.5 or 14.6, because it's physically impossible to have a child who is 0.6, right? 0.6 of a student, you can't have it. You can't have a quarter of a student, you can't have a half of a student, right? So then it's always in whole numbers. So it's not continuous. It's going to be 1, 2, 3, 4. It's going to be like a shoe size, right? So our shoe size won't be continuous. It's 28, then 26, like that. So it's like shoe size and the number of the population, the number of students, number of family members, yes or no, that's binary, right? Yes or no. So there's only two possible outcomes. So these all will come under the classification problem. Now let's take a look at it with an example of a tap case. Okay, so when the tap is slightly open, we know that the water drops out drop by drop. Here, first drop, second drop, third drop, we are able to count, which means it's not continuous, it's discrete. You're able to count, and we can say in total there were 10 drops. That's what we call as a classification problem. So what we see here, drop by drop, is a classification problem. On the other hand, this is called a continuous, because when the tap is completely open, the water just rushes out, and it's a continuous process, right? It's continuous. You can't count the number of drops. It's physically impossible to count it. So then it comes under the regression problem. Now, since we already learned what a classification and regression problem is, we know what supervised is, I have a question for you. Here is a data set, right? Now it says it's labeled data, so we obviously know it comes under supervised learning. What I want you to know or do is guess if it's going to be classification or a regression problem, right? You can see the data, learn the data, see the variables, especially look into the target variable, see what type of target variable, what is the type of target variable, and tell me if it's going to be classification or regression problem. If you guessed it is a classification problem, then yes, you're right, it's a classification problem. And why is that? Because the target here is paid or default. Okay, so there's only two possible outcomes, paid or not. These are the only two possible outcomes when it comes to this problem. Then it's not continuous, the value is not continuous, it's discrete. So it's a classification problem. Pretty simple. So I assume that you must have understood the difference between classification and regression by now. Moving on, let's discuss about decision tree algorithm. Decision tree algorithm is a very famous algorithm, right? Now let's learn what it is. From name we see a decision and a tree, but let's learn what it is. What is decision tree? Now, decision tree comes under the classification of supervised machine learning. Supervised machine learning in the sense the data we use is labeled. For training the algorithm, we use labeled data. Now in supervised we have two, classification and regression, right? So decision tree can be used for both classification and regression problem, in the sense what type of data the target variable is, whether it's discrete or continuous, doesn't matter, we still can use decision tree. But we commonly use it for classification, that is for discrete variable. Next is the basic concept behind decision tree. What decision tree does is that is a large data set. It breaks the large data set into a smaller data set, and that smaller data set into smaller sub data set. So it breaks the data set into smaller and smaller subset. This is what decision tree does. At the same time, while it's breaking, it would build a tree. That's why we call it as a decision tree, a tree that has the ability to make decision. Now, when we talk about decision tree, your imagination of a tree would be something like this. But there's a slight change in that because the tree is going to be inverted. Something like this. So what does the inverted tree mean? We are starting from the roots. And from the roots, we move forward to the branches. And from the branches, we move forward to the leaf. So this will be our flow from roots to branches to leaves. So it's inverted. It doesn't go from leaves to branches to roots. It goes from roots to branches to leaves. So it's an inverted tree. Now let's see how you can see the flow chart, right? First, there's a root node. This root node represents the entire data set that you are using. This data set is divided because it divides data into smaller and smaller subset, right? So this data set is divided into decision node, and this decision node is further divided into leaf nodes. Now leaf nodes are the final stage. It's the end point. You cannot further divide a leaf node, but you can divide a decision node into further decision nodes, right? And these decision nodes can be further divided into leaf nodes. This is the basic workflow, basic flow chart of decision tree. So this is how a decision tree basically works. Now here we saw the root is the root node and the leaves is the leaf nodes, but in between we learned something called branch. Where is the branch here? So what we see here, decision node, leaf node is what we call as the branch. Okay, let's move forward. Let's learn the basic terminologies we commonly use when it comes to decision tree, right? So first, root node, then we have splitting, then we have decision node, then we have leaf or terminal node, that is leaf node can also be called as terminal node. Then we have pruning, then we have branching and or called as subtree. So branching we already saw. Then we have parent node, and then we have child node. So now let's discuss each of these one by one. Let me explain to you what it is one by one. You already might understand what it means from the term, but let me also explain it to make it much more clearer, right? First, root node. So root node is I already said it's the entire data set which is going to be divided. So it's the entire data set, or you can call it the entire population or the entire sample is what we call as the root node. Next is splitting. Splitting is the process of dividing into subnodes, right? Dividing subnodes into more subnodes is what we call as splitting. Next we have decision node. So the subnode that gets formed from the node is what we call as a decision node. Next we have the terminal or the leaf node. Leaf node, like we know, it's the end point. So a node that cannot be further divided into subnodes is what we call as a leaf node. Next we have pruning. Now pruning is a bit of confusing term because it is actually removing the subnodes. You can kind of imagine it as the opposite of splitting. In splitting, you're forming the subnodes by dividing. In pruning, you're removing the subnodes, right? Next we have branch or subtree. We already know what branch or subtree is. We saw an example. Then we have parent node. A node which is splitted into subnode is what we call as parent node. And the child node is the parent node gets divided into child node. It's obvious, right? The subnodes that are formed from the parent node is what we call as child node. Like it's the basic principle, right? Parent gets split into child node, right? And next we have the benefits of decision tree. Now, first benefit is that it is very easy and simple to interpret and visualize because it's like an if-else statement, and we already visualized a tree and you understand, right? Anybody who is not even in the field of machine learning can understand how the algorithm works. Next, we don't need feature scaling. When it comes to decision tree, there's no requirement for doing feature scaling. And it can handle non-linear parameters. Your input variable doesn't have to be linear. It can be linear or non-linear. and it can handle missing values and outliers. Some algorithms can be sensitive to missing values and outliers, but decision tree is not sensitive to missing values and outliers, so you don't have to take your time to remove missing values and outliers. Next is the training period. Now when it comes to decision tree, there's only one tree formed, right? We divide the data into subsets and we form only one tree. But there is other algorithms like random forest where it's a forest, so there's going to be a lot of trees, so it's going to form a lot of trees, so it takes time. But since decision tree forms only one tree, the time taken for training is really less. Next, let's look at the drawbacks of decision tree. So the first and foremost is it leads to overfitting. Decision tree leads to overfitting. That is the biggest problem of decision tree. Next one is that decision tree can be unstable. There is various algorithms that can be unstable, and decision tree is one of them. Plus, decision tree is sensitive to noise. So if your data has noise, you will have to remove the noise, then train the algorithm. And it's not suitable for large data set. Each algorithm requires a minimum amount of data set, and for decision tree we have to give an average amount of data set, the medium, which if you give a lot amount of data set, it might lead to overfitting really easily. Okay, now like I said, we're gonna do the coding. Here I'm gonna show the coding in Jupyter Notebook IDE. So we're going to look the coding in Jupyter Notebook IDE. I have already done the coding here, so that will be easy for me to explain, right? So I have used the data set from Kaggle, credit card defaulted. This is the data set. I've already explained this, right? Credit card default versus students. It's the same problem. From here I have downloaded the data set. You can also go ahead and download and try this problem by yourself, because when it comes to machine learning or anything for that, when you have learn by practicing, then it's the best way of learning. Now here's the problem. First stage, whenever we do a coding, first step is to import all the required packages. So these are the required packages. First one is pandas. Pandas is a very common package. It's the basic package you learn in Python. So it's used for data frame, to store the data into data frame and then edit. For all the stuff we use pandas, right? So for loading the data set we use pandas. Then from SQL and pre-processing we use label encoder, because as we know, the some of the data here, like the default and the student, is a categorical variable. It's in yes or no format. We have to convert it into numerical form so that the machine can understand the variable, so that we can train the algorithm. For that we'll be using label encoder. Then from the scalar model selection, we're going to use train test split to split the data into training and testing, or the training and validation data sets. Right, then we from sklearn tree we're going to import the decision tree classifier. That's the algorithm we're going to use. And from this decision tree regressor as well, since our problem is a classification problem, we're going to use decision tree classifier. And then from a scalar metrics we'll be using accuracy, classification report, and confusion matrix. These are the commonly used scores to test the accuracy of the algorithm. Right, first step, we're going to create a data frame called data and load the file, the CSV file into data, and we're going to check if the right data has been loaded into the data frame. So by using data.head we can get the first 5 input, the first 5 rows, right? So default, student, balance, income, perfect. This is the data set. Now we have to convert this yes or no into numerical data. For that we're going to use the label encoder. So first we have to initialize label encoder, then into data.default, the same column we use here. In data we are going to use the default, right? In data, the default, we are going to fit transform the label encoder. We're going to train to data.default. So we are going to change transform data.default and store it in data.default. Same here, we're going to transform data.student, we can transform data.student and store it in data.student. So after doing the transformation, you will get numerical values like this 0 0 0 1. So 0 is for no and 1 is for yes, right? 0 here you can see these are all no. Here we got zeros for the no's, and here we can see that this is no, we got 0, and for yes we got 1. So 0 is for no and 1 is for yes. Now next stage we have to define x and y. X and y is the independent and dependent variable, right? So x, we can call it as the input or the dependent variable. So in this problem, our x is our independent variable is student, balance and income. So the number is 0 1, so 2 3 4. So we have loaded 2 3 4 into a variable called x, right? And into a variable called y, we are just loading default. Default is our target or the dependent variable. Now we are just checking if it has been correctly loaded. So in x we have the student balance income details, and in y we have the default, so it's mostly no, right? So we have the default. Next stage is to splitting the data set into training and testing, right? So we have to split the data set. For training, we have to train the algorithm using a data set, then we need to test the accuracy score. So for that we have a testing. So this is the format the variable should be ordered: first x train, then x test, then y train, then y test, and then we just simply call the function x train to train test split function, and pass our x, which is the independent variable, then pass our dependent variable, give the test size. Test size is the splitting size. So how much percentage of the data do you want it to be test size, and how much percentage do you want it to be training size. So here I've given 0.2, that is 20% would be the testing size, the remaining 80% would be training size. And random state is any, just you have to give any random number. It could be any random, you can give 14 15 16 17, and I gave 27. Okay, so just giving a random number so that the test size won't change every time you run it, right? Next is defining the model. So into a variable model, we're going to put the decision tree classifier algorithm we have imported. Then we need to train the model. So using model.fit and passing the x train and y train, we are training the model. The model needs the x train, which is the independent variable, and the y train, which is the dependent variable, and we train the model. With the trained model, we need to test. So we are forming a y predict, right? This is a variable, and we are asking the model to predict for x test. We are giving only the independent variable, and we are asking it to predict the y for it. So we are checking the y predict. Here it's 0 mostly, and here also you can see it's 0 mostly. The y test is the actual prediction. Now we are going to compare the y test and y predict and get the accuracy score. Here our accuracy score is 0.95, which is not bad, right? It's good. It's a good accuracy score. Anything above 0.8, that is 80%, it's good accuracy score. So 95% is a really good accuracy score, but it can get better. You can get up to 99, even 100 is possible sometimes, right? Moving on. Next, we're going to check the classification report. For classification report, it's important you give print of classification report, or else the data is going to be unreadable. So for it to be organized in a table format, you need to give print of classification report. And in classification report, we can see for 0, the value is 0.98, 0.98, 0.98. That's really good score, right? 0.98. The precision, the recall, and the F1 score is the average of precision and recall. So 0.98, it's a really good score. But when it comes to 1, the score is very low, 0.38. The average is 0.37. It's a really low. So we need to improve on this. We need to work on this. And then the confusion matrix. So we can see here for 0, there is 1930 records. For 0 there's 1930 records, out of which 1887 was correctly predicted. Really good. 1887 was correctly predicted, and only 47 was predicted wrong, right? And when it comes to 1, there was only 70 records, so I guess the data must be imbalanced because there's only 70 records, and out of 70 only 26 is correctly predicted. Remaining 44 has been predicted wrong, so that's a mistake, right? So this algorithm has been trained in imbalanced data set, so the data is not balanced. It's important for any algorithm that the data has to be balanced, because if the data is not balanced, then it can lead for the model to be biased towards one of the point. Here we can see the model is biased towards 0, that is no, right? No means they would pay it. Default means 1 means they would not pay, right? They would default. Okay, so this is the basic technique. We just use the model, and this is how you do the coding for decision tree classifier. It's not that difficult at all. It's very simple procedure. When you code and see, it's very super easy. So this is basically about decision tree algorithm. So today we have learned about machine learning, what machine learning is, and we have checked about decision tree, how decision tree algorithm works, and the basics. I hope you understood everything. Thank you so much.